Welcome to episode 297 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm all right, Rob. How are you doing?
Doing all right. I realize we haven't talked about conferences in a while, but C++ Now is coming up soon, right, Jason?
Yeah, it's like next week. Yes, it's next week. I should know that. Because it turns out I'm speaking at it now.
Turns out you're going to be speaking at it. What are you going to be talking about?
The title of the talk is The Worst Best Practices, and it's kind of, okay, I'll go ahead and give a little sneak peek here. So the premise of the talk was going to be that I would talk about, just the process of writing a book in the 2020s and what that looks like, self-publishing and whatever, and then what kind of controversies or whatever that I might have brought up by publishing a book on best practices. Interestingly, it's kind of turned into a little bit of like a 15-year retrospective, because I realized as I was starting to write the notes for the talk that my first notes writing down things that ended up in this book were 15 years ago.
Oh, wow.
It just makes me feel old. So in a way, the book is 15 years in the making.
Very cool. And are listeners still able to go get virtual tickets for C++ Now? Do you know?
Oh yeah, they definitely still want people to sign up.
Okay, so that's cppnow.org, I believe.
Yeah.
Okay. Well, at the top of every episode, I like to read a piece of feedback. This week, we got an email from Rory saying, "Love the podcast, one of my favorites. I saw this post recently, and I'll link to that in the show notes, regarding modernizing C++ support in the Open JDK VM, which has some interesting notes on the specific features they feel would be beneficial to permit in the codebase from recent C++ standard iterations. I thought it may be interesting at some point to hear from one of the devs on the project, which is one of the most widely used and deployed runtimes written in C++.
That is interesting.
I thought this could be a good topic for a show. We did do one show about Java a while ago, but Java from the perspective of, this Java VM written in C++ and specifically to the JDK, the Java Native Development Kit. I think that's what they're talking about, right?
JDK Java Development Kit, yes.
Yeah. And their support for C++, I think, could be an interesting topic.
Yeah, okay, now I'll just make myself sound old again. But OpenJDK has its own whole history because there wasn't an officially licensed Sun version of the Java virtual machine for Linux back in the mid-90s when it first came out. So there became an effort at the same time. I'm pretty sure OpenJDK actually goes back that far, back to 97. That sounds right.
Did not know that. Okay, well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is JeanHeyd Meneide. JeanHeyd is a student at Columbia University in New York. Most of their programming is for fun and as a hobby, even if their largest open source contribution, Sol 2, is used across many industries. They are currently working towards earning their own nickname, climbing the academic ladder, while spending as much time as possible contributing to C++ standardization and development. Their newest and biggest project is Unicode for C++. They also very much love dogs and hope to have his own in a year or so. They also like TWRP's Feel Pretty Good from the album Together Through Time. JeanHeyd, welcome back.
Hey again. I think this is the third time I'm here.
Fourth?
So
if you include the time you guest hosted.
Oh yeah.
That makes it 4. Wow, I've been on here a lot.
So who's the record holder at the moment?
I believe it's still Sai, I think.
Has he been there like 6 times?
Something like that. I could look it up real quick. But I believe Sai Brand is has been on the most. Yeah, 6 episodes.
Nice. They've got a good record.
Yeah. All right. Well, JeanHeyd, we got a couple news articles to discuss. Feel free to comment on any of these, and we'll start talking more about what you've been up to lately, okay?
All right, awesome.
Okay, so this first one is a post that was on the CPP subreddit. Just discovered C++ has keywords for and, or, not, etc. And that is like the word and spelled out, which you can use instead of the common and operator. And the code sample for this like really kind of hurts your eyes. I definitely didn't know this was something you could do. What do you think about this?
So I know about it, and I'm aware of the keywords. I've kind of decided not to use them at the moment. But I think that's mostly because MSVC beat them out of me, because all their compilers just work normally with them. But with MSVC, if you don't have the permissive flag or whatever, you have to include a header to get them.
Right.
So it's actually a pain and a half to use with MSVC. Again, most new products default to having /permissive on and all other stuff. But other products don't, and so people kind of complained when I did use them, even just in jest a couple of times. So unfortunately, I wasn't able to really get used to them so much. I kind of I trained myself out of them, which is a little bit sad, because in some cases they do make things nice, especially when you're working with templates and you're like composing the gigantic conditionals that go into like a template. And you just have like a little, exclamation point in some places to negate stuff, and it's like it gets completely lost in the line noise. So just having not space is like a really good visual indicator. It's like, okay, I'm negating this thing in my 4 or 5 lines of template shenanigans.
If you have 5 lines of spinne, you've gone too far.
Yeah, I mean, that's what we'd like to say, but then you look in the standard and the constraints on certain constructors is not a array, and is not, it does not decay to an element of the base class type. I was like, oh my god.
Yeah.
So some of us take that advice to heart, but the rest of us not so much.
I actually know one team that uses this exclusively. They don't use the traditional operators.
Oh wow.
What is their reasoning for that?
They would say readability.
Okay.
Actually. But then every compiler implements it in a way that's not, in my opinion, quite right. And so if you look at the first comment on the Reddit discussion, my class and other, and you just put like an R value reference by using the and keyword there. And like every compiler allows that, and it's not quite right somehow. And so that's my feeling on it, is like, nah, okay, never mind.
Yeah. I think what was the first comment after that one is, thanks, now I hate it.
Yeah.
Yeah, that'll definitely do it.
I'm assuming that the team you're referring to, Jason, probably would not write that code, but they're using the actual logical and. It would
yes.
Yeah. But I mean, would it really be C++ if there wasn't a fun way to shoot yourself in the foot with it, or write something crazy with it, right?
Yeah. Okay. Next thing we have on the topic of virtual C++ conferences, Pure Virtual C++. The sign up is now live, and that's going on next week. So if you haven't already signed up, you should check it out.
I guess that does overlap with C++ now.
I guess so. I don't know. This is just a single day. This is May 3rd.
Yeah, it does overlap. Yeah.
Okay. And C++ now is that's what, 3 or 4 days?
Yeah, it's the 2nd through the 5th. It's a 5-day conference. It's usually 5 days with I don't know.
Yeah,
I don't know what the schedule looks like.
Yeah, it's usually just like a week, or for the business week. That week is when it lasts. But yeah.
Yeah, I should probably figure out what's going on there. Sorry.
Yeah, but I'm kind of excited about Pure Virtual C++. I think I'm definitely excited about Daniela Engert's talk, the 3 secret spices of C++ modules. Because I have I don't know how to use modules properly. I mean, so I've seen Daniela give some of the talk before, and I've seen like build improvements, other things that can come from modules. But I think that this talk is probably a more improved version of that, because the last time she gave the talk, she was basically fighting with, all 3 compilers that had incomplete implementations of each modules, and they each were incomplete in like completely different ways. So you had to tailor your code for each different one. But basically, I think this will be a much more improved talk. And so I think I'm interested in watching that one, so I can learn a little bit more about it. Also, because I need to work the hatred of modules out of my system steadily and slowly. I ran into some unfortunate things about modules and the way they interact with the preprocessor when it comes to StandinBed. And so my life was just the whole proposal was thrown into limbo because I had to figure out how to make this phase 4 hash depends things work with StandinBed, and it's kind of a mess, and so I got to figure it out, which is a little bit unfortunate, but that's where I am.
That's a fascinating.
Sorry, go ahead, Jason.
Fascinating overlap for me from a C++ weekly perspective, because like once every 10 days, I have someone ask me, when am I going to do an episode about modules? And I'm like, I don't know, after the compilers support it and I know what I'm talking about, right? But then also, I just had someone recently say that I really need to do an episode on StandinBed. So,
well, StandinBed is going to take a little bit longer. So you won't have to do an episode that quickly. But you will be able to. You should hopefully be able to do an episode on embed. Which is the preprocessor version, which isn't quite as powerful as StandinBed, right? So StandinBed, you can use a constant val time, you can use it to like recursively, because it's just a normal constant val function, you can use it recursively at compile time. You can basically implement like a C compiler in, C++ constant val using this kind of thing, right? Hash embed is a preprocessor thing. You can't react to the fact that the preprocessor included and then hash embed something else, so you can't get that recursive ability anymore. We also remove the ability to specify types with hash embed. So all you get out are just blobs are basically a bunch of numbers. The way it works is that it basically dumps out a bunch of numbers that go from 0 to whatever the UCAR max is supposed to be. Which is basically 0, 2, 5, 5 on all normal, regular, sane systems. So, and that's just kind of what it does. And so it's very simple in that way. But again, you don't get to do types. It's not constant val. You can't react to things. So there's a lot of room, I think, left on the table for StandinBed. But I think hash embed is like a very good thing for like quick fixes. And just people who just like, listen, I need a data array and I need it right here, and I just need to splat out all these numbers. I need the compiler to not, spend 5 gigabytes of RAM trunking through this gigantic array that I wrote, right? So that's good.
But it is a string literal or an array literal. No, that's not a good word. Yeah, it is. It's.
The way it literally just actually dumps out numbers now. So it doesn't include the curly braces. So it's supposed to behave like a comma delimited list of numbers, right? So a naive implementation could do the wrong thing where they just kind of vomit out the numbers in the spot and say I'm done. But most of the implementations have had some amount of optimization put into them. For example, my experimental implementation uses a built-in that sits in an array and expands to the right thing, and it's really fast, and obviously it's cutting edge. And there's a bunch of numbers on the GitHub page, github.com/the/embed or whatever. It's literally just acts as if it dumps out a bunch of numbers, and that's how it works.
So can I use this on any compiler that's currently shipping?
No, not yet. But good news is that I synchronize with both C and C++. So I think it'll take a little bit longer to get in C++, but C is interested, and it's actually getting pretty close to acceptance. It might actually get accepted either next meeting or the meeting after. So it'll be in C23. And that means, and the good thing about that, it means that Microsoft can't escape anymore. And they can't keep pretending that they, their 65,000 bytes or whatever limit for string literals is good enough. And we'll actually have a way to put large data files in MSVC without, waiting, like a million years for it to finish. So, and that's actually like 99% of why I'm standardizing this, because MSVC didn't fix their string literal processing. So that's it. That's why we're here. And so now in my vengeance, it's not only going to be in C++, but it's also be in C, so that, if anytime they implement the next standard, it's going to be there and they can't escape.
That's hilarious.
Nice. Yeah. Okay. And then the last thing we have is just the collection of papers for WG21 for April. A couple new ones here. I didn't read through some of these in too much detail, but I did see a couple interesting titles, like Constexpr class. I thought that one might interest you, Jason.
I missed that one. I missed that one. I usually just search these things for Constexpr.
It's 2350 by Andreas Fertig. Fertig, yeah.
2350.
Yeah. Are you familiar with that one, JeanHeyd?
A little bit. So I saw some of the discussion that kind of led to its creation. But basically, I believe the idea here is that
Oh.
you can essentially mark a class as Constexpr, and then rather than going through and marking every single member function Constexpr, it just assumes that it's Constexpr.
Oh,
yeah.
Everything inside is Constexpr. So you basically say this class is Constexpr, everything inside is supposed to be Constexpr, right? And it helps catch class of errors where you forget to Constexpr something. And there's been implementations that have shipped stuff, and they're like, oops, we forgot to Constexpr this thing now. I guess we have to wait till the next update to get a properly Constexpr, variant or whatever else. Yeah, I think it's helpful. I think it's good to just make things easier, and not have, people accidentally dropping Constexpr on the floor. It also kind of signals intent better. So if you forget Constexpr on a single method, someone's like, did you mean to forget it there? Was that like intentional? But if you just put it on the class and it's like, okay, everything in here is supposed to be Constexpr, like that makes sense, right? So I think it's a good thing. I think it'll be great. I think the only thing that this proposal doesn't do is it doesn't allow you to backdoor your way out of it. So if you put Constexpr on the class, you can't mark individual methods as, oh, by the way, no, I don't want the Constexpr here. So
we need the no Constexpr keyword, so you can put no Constexpr in front of the
in front of the method. So there's a tiny amount of precedent for this. Some people have already proposed like a Constexpr with parentheses and a Boolean, and then you can kind of like do static compile time math to say whether it should be Constexpr or not. It was rejected, but I think maybe with this proposal there might be some need for it. I do think that there might be some cases or classes where most of the thing is compile time, but you want to specifically say this thing though is not a compile time method. Like I have a caching method or something, right? And that works off a runtime cache that I'll never be able to access at compile time. This method can't be Constexpr, right? So I think those kinds of cases will be a little bit important. I haven't told the author this, but maybe I can just talk to the author and they can see how they warm up to that kind of idea. But yeah, I think it's a good paper. It's a good paper.
Yeah, I had totally forgotten that I had seen this discussion on Twitter. He was soliciting feedback for what the layout should look like for the paper. I mean, where the Constexpr keyword should go specifically.
Yeah.
Any other interesting papers either of you want to bring up in the April mailing?
Well, there's another one from Andreas that I did see, which was making unique pointer Constexpr, which in my opinion is like a huge oversight from C++20, because if you've got Constexpr vector and Constexpr string, you can make unique pointer Constexpr. That should have just been done. But anyhow.
Yeah, so that one's got to get in too. That's like, for obvious reason, that'd be a great idea to have. That'd be a great thing to have. So I'm looking forward to that one definitely. But I think that's. I mean, I put a paper in there, but it's just it's a old rehash of a paper that I had for what is it, reconstructible ranges. I think I talked about that a couple of times before and wrote a lot of blog posts about it. But basically, it's a paper just if you take a range apart into its iterators, you should be able to put it back together, or you should be able and do some other cool stuff with it. So that paper is back in the fray now, maybe for C++23. Oh, and that's right. So outpointer.
I was wondering about outpointer. Yeah.
Yeah. So outpointer's in this mailing because it actually got through LWG review. So it's going to be in C++23. So you'll be able to take smart pointers and have them interact with C-style functions that take like double pointer, output pointer parameters and stuff like that, and it'll just make them magically work.
Oh.
So that's going to be approved for C++23. I was hoping that the paper would come along with Isabella Muerte's retain pointer, the intrusive pointer style kind of pointer. But unfortunately, that's got to spend some more time in LEWG and stuff. So library evolution work group, the design group, before it goes to the wording group. But yeah, I'm super glad that outpointer made it. And it was a very long time coming. And I'm actually kind of really glad that's in. This is one of those small things that I don't think is a big deal, and a lot of people don't think is a big deal, but it turns out that a lot of people keep re-implementing it over and over again. And it turns out that there's some performance optimizations that only the standard library can do that I've actually been doing in my implementation, but through UB type punning. So I reach into your unique pointer and I cast it to a struct that has like the pointer and deleter, and I rip out the pointer from it and then throw it in the throw it in the out pointer, which is pretty illegal, but it works. So I'm,
well, in a way, it's not illegal to type on the same initial sequence. That's the same initial sequence rule. It should allow that, right?
So sort of, right? I don't actually know if the struct I'm using matches what the compile. Like, so basically I have like a bunch of if steps for like, is this lib C++ do this? If it's lib stud C++ do this? If it's Microsoft do this? So it's pretty illegal. They can change it at any time, right? It's not guaranteed to work. I don't think they will because, ABI stability and all other stuff, but it works on very shaky and tenuous ground. If the compiler decided to be mean about it, like, they could ruin my day. So I'm just glad it's in the standard now and I don't have to keep shipping radical undefined behavior to people, which is great.
Okay, so should we break the ABI or not?
Yes. Yes. But oh my god, like I want to go on such a bad rant about ABI, but we will not get to any other part of the show if we start talking about ABIs. I will completely refrain from doing that. But to sideways answer your question, yes, you should break ABI, which means yes, that my out pointer implementation that I'll have out in public would break sometimes, right? Mm-hmm. I'm perfectly okay with accepting that breakage if that means we don't, ruin things for a lot of other people and ruin things in I think more insidious ways than I think people realize. But again, I'm resisting the urge to rant so badly. Yeah,
a little rant.
To distract you, I'll ask you your opinion on one other thing in this mailing, and that's the if const eval, to get rid of the if is constant evaluated.
Yes. So I actually I was actually pretty against if stud is constant evaluated, like the spelling of if and then no Constexpr and stud is constant evaluated. I think that was a huge mistake. Almost universally, everybody who reflexively uses it types out if Constexpr stud is constant evaluated, right? And that's subjectively the wrong thing to do, but it feels so right. It feels like exactly what you should be doing, but it's objectively the worst thing you can do with that feature, because what it says is if evaluated at Constexpr time, this condition, right? So the condition has to be evaluated at compile time. So stud is constant evaluated will always return true. So if you say put slow code in the const eval path that's Constexpr friendly, right? Like you've just tanked the runtime of your algorithm forever. And because it's Constexpr, that is a subset of valid C++, right? So you will never notice that you're always taking the wrong branch if you write that code. Unless you just notice a massive performance degradation or something, right? So it's very painful to have the thing. So if const eval removes that because it's just if const eval, and it's very clear that you want to switch on the fact that it's compile time or not. I've softened my objections to stud is constant evaluated a little bit because some people have done interesting things like this. So they have an if statement, they say stud is constant evaluated, and then they add a bunch of other conditions for like other things that should be true along with the constant evaluation. And so people develop complex expressions for that. And I think that some of that is a little bit necessary, especially because of the way if Constexpr, if const eval, and some of that stuff works. Like if you use an if block, it introduces a new scope. And sometimes you want to share some code, and if you have to put it in like an if block, an if Constexpr block, whatever, and you introduce a new variable, like you can't like really write over it or set stuff. And so I think that there's still some room for if stud is constant evaluated and some other stuff, but at least we have if const eval now, so at least we can drive most people who will just be doing the basic is this compile time or not switch to use if const eval and do the right thing. The people who have more complex conditions can drop down to a lower level of abstraction. The stud is constant evaluated and make complex stuff happen.
That's an interesting point, because I was kind of wondering if this would effectively deprecate is constant evaluated.
Yeah, I think for the most part it kind of does. But there's some of those advanced use cases where you need like an expression that can be slotted into an if statement or something else, right? Like there might be cases where, for example, you want to base the note. Well, no, that doesn't work. There are some cases where you want to be able to mix that expression in with other things that aren't evaluated at compile time, and also want to avoid a little bit of code duplication. So instead of having a nested in if const eval, which makes a new scope, and then you have to fill everything in there, you can kind of mix things a little bit, which I think is okay. So yeah.
Okay. Well, JeanHeyd, I know you're always a very busy person. What have you been up to lately that you want to talk about? Where should we start? Maybe what you've been up to with the C Standard Committee? We talked a little bit about embed already.
Yes. So the C Standards Committee is making amazing progress. At least amazing from my perspective, because if I went in there, I was like, nothing's going to change. I'm going to spend like 5 years here, and nothing's going to happen. We'll fix some UB in some libraries somewhere, and then like that'll be what we're doing. But no, the C Committee has pleasantly surprised me in that they are very hungry for fixes to a lot of their problems. Right. So they were receptive to embed. They were receptive to a lot of different other papers. They're even talking about a defer feature for C. And I'm not sure if it'll make it for C23, but I'm actually really excited about that.
What was the feature? Sorry,
what would that be?
It's a defer feature. So it's not exactly like Go's defer. It's basically kind of like it's like Destructors for C, right? So you make a defer block, and you basically say all the stuff in this defer block, it gets executed at the end of the scope, right? In its simplest form. And so it essentially it's basically like a destructor, right? The lifetime of the defer block ends, you run all the statements in the defer, right? So you do an F open, and then you put your F close in the defer, and then whether you go to or whether you return or whether you just jump out of the scope or whatever else, that defer code is run.
Like a destructor for a function, effectively, is what it kind of sounds like.
Basically, but it's scope based. So you can have a defer inside of an if clause, and when you exit that if clause, then that's when it it engages when you enter the if clause, and it fires when you leave the if clause, right? So it's very much like the destructor. And
can we get that plus too?
I hope so, but right now we're focusing on doing it just for C because I think C needs it most. And the person who's pushed the paper, Robert Secord, I've spent a lot of time working with a lot of people kind of trying to make it happen. He has he gave presentations on it. He's working really hard on it. I actually do think a lot of people think that it's just destructors for C, but it's actually literally fundamental than destructors. So destructors are always paired with constructor, and they're a general purpose undo mechanism, as Scott Myers had said. But destructors also carry with them some baggage, especially when it comes to the standard library. One of the reasons we don't have scope guard, that thing that Peter Sommerlath was working on for a million years, that was the realization of Andrei
Alexandrescu wanted it. Yeah,
it was his idea for if there's a transaction and something happens, roll back the action, right? And so that was modeled off of using constructors and destructors, right? So constructors set up the action, and then based on conditions, fire any number of these, transaction failed, or the block exited normally, so it's okay, or the block exited with an exception, so do this instead, right? That kind of thing. And so Peter Sommerlath created this paper, I think P0052, that was scope guard, right? That was what the paper was about. But fundamentally, that paper doesn't work with the standard library because every single type in the standard library must have a no except destructor, right? If anything is destroyed in the standard library, it doesn't throw an exception, right?
Right.
We take this so far that even for things like file buff or threads or whatever else, right? Like any exception that happens in the destructor, we just swallow it and throw it away. Every single standard library does this, right? And even in some place in the wording, we say if an error happens while the destructor is going on, just swallow it and just throw it in the trash.
Students made me aware of this because apparently close can fail, which I had never considered, that file close, not F close, but like OF stream close could fail. Like it might not have enough disk space to write to it. And if you're just relying on the destructor, as I do, then you completely miss that an error may have happened when the file is closed.
Yes, exactly. And so one of the reasons why scope guard couldn't make it into the standard is because we would have to fundamentally reevaluate what is the stable tag name, res.on.exception or whatever. But basically that says no standard library type will have a throwing destructor. Every single destructor will be no except. Will be no except, and we will never have a no except destructor. And the single thing about scope guard is that we're running arbitrary functions, and some of them can throw, and it's desirable to react to that, right? Especially if you have nested scope guards where you're testing if something upstream failed, then yes, even if this scope guard failed, the next one should be able to catch it and do something about it, right? But the way the standard library works is that every single type inside the standard library can't throw. So you come up to this very strong barrier between the rules of C++ standard library and this very useful functionality. And the reality of the matter is that you you really can't have it in a C++ standard library that goes full in on not having any kind of throwing destructor. So the only way to have this feature is to actually have the defer feature that C is working on right now, because the language doesn't particularly care if you throw or not in a destructor. That's just whatever. Yeah. But if object throws, if a standard library object throws, that's a big problem, right? So by having defer in the language, you can get around the fact that the standard library can't handle this kind of thing. And so now you can write a defer clause that does all the things that Andrei Alexandrescu had envisioned with scope guard, without needing the class boilerplate and having to create this type that holds it on this lambda for a million years. You can just have the first statement do it instead. And so that's actually a huge win that I don't think a lot of C++ people realize is there for people who want to do better transactional programming, or better guaranteed if somebody throws an exception or whatever kinds of programming without having to roll their own scope guard or whatever that entails. And so I think the defer statement actually has immense value to C++, not just C. And so that's what I mean by it's not just destructors, because again, destructors have this connotation that they're always no except, right? And of course, you can't pass arbitrary information to destructors unless you pass it into the constructor of the object, right? And then you have to hold it and stuff like that. But defer can do it much more efficiently, right? Because just again, this is a scope-based statement. So I think that actually has a lot of room. I'm actually very excited to see where it goes for C. I expect that C will get it first, and then slowly we'll have to start whittling out the C++ committee, be like, no, listen, this defer thing is actually really cool. It's not just destructors. Like it's actually it's a more general purpose undo mechanism than what Scott Myers had said was a general purpose undo mechanism, constructors and destructors, way back when. So I think it'll take a while to warm these people up to it, but that's what I'm talking about on CppCast. You can put the idea in people's heads and like, defer is a good thing for C++. Yeah, that kind of thing. But we'll see how it goes.
I have questions.
Yes.
Like, when you're in the defer block, is the previous scope, is it still visible to you? Do you have access to those? You must, because otherwise you couldn't call fclose, for example.
Yes. So you have access to everything in the previous scopes, right? So it's basically like you can just refer to everything there, and it works. You can also, if you want to be like safer about it, you can like capture a lambda and like capture the variables by value and then like pull things in that way. Again, to make things safer. And C is also, there's also another thing that's actually exciting about C. C is working on getting lambdas, which is,
oh wow,
that is a big thing. But I think it's a very big deal for C, because a lot of higher level programming in C is basically done with extensions, like either nested functions, or I think I learned that Borland C has like a special like wide closure type, or a double underscore closure keyword that you can annotate with function pointers to make a closure type that contains both the function and like more data and stuff. So I learned a lot being part of the C committee and being the product editor. But yeah, they're getting lambdas, and so that thing might help with lifetime and other stuff that comes up with how defer works. But I think that because defer is locally scoped, like you can't eject a defer into a higher scope, right? So fundamentally, right, you're going to be running the defer with all the variables that you reference there. So you would have to like allocate a variable, delete it, and then run the defer in like a smaller scope in order to like make that kind of happen, right? So it's still safe, but obviously you still run into the problems of if I capture something by reference or by pointer in some other scope, then obviously you can reference it in defer and then blow something up. But it has the same kind of properties of that, it always deletes stuff at the innermost scope, and you can't like, accidentally refer to something that by value rules would have blown up by now, right?
Okay. Yeah, that's what I was wondering, is if the destructor of an object were to throw an exception, and then I pop into my defer block, how do I know which object threw that exception in its destructor, and what happens if I try to access it? But it sounds like that would not be possible.
Yeah, so I think defer would run before the destructors would run.
Okay.
And so that would prevent. Now, again, they haven't really hammered out these details, because again, in C, there's no destructors, right? Everything, the object lifetime ends when you leave the scope. Defer is before you leave the scope. So for them, everything's kosher. I think in C++ you'd have to have the discussion of when exactly does defer run. My preference would be before destructors are called, because you want to, you want to be able to access things still.
Yeah, I think it would have to be.
Yeah.
Like either that, or you'd have to like figure out a way of like, you'd have to say that the first statement triggers in the order of declaration, right? So the same way that destructors are done in reverse order, right? You would do the reverse order of destructors, and then whatever the first statements happen to interleave with those, right? In that kind of order. So if you declare one variable, do a defer statement, and declare another variable, right? You delete the second variable first, then you call it defer, then you do the first variable, right? Like in that kind of reverse order. So you can maybe do it like that. But again, that's probably the best way of doing it, I think.
Okay.
But so basically anything that you could refer to and defer would be anything that comes above it, right? And by that logic, like everything above it has a lifetime that is longer than the first statement, right?
Right.
Because things are always destroyed in reverse order. So anything declared after it would destroy itself before the defer block runs, and you can't refer to anything after the first statement. So it has the same kind of rules as the destructor, right? So
it kind of starts to feel like if init blocks, where when you show someone if init, they don't expect that the else block would have visibility to the thing that was in the if init statement. And then if you nest them and nest them and nest them, like if init, whatever, then by the time you get down to the fourth if statement, you actually have visibility to all of the previous init blocks. People don't expect that, but once you understand how it was structured, then it makes sense. And I kind of feel like what you just described feels the same and would make sense once you maybe you wouldn't get it immediately, but then you'd be like, oh, okay, I see what's happening here with the interleaving.
Yeah.
Okay.
But yeah, so that's how what's been going on in C-land. I'm actually working really hard. They added a new annex to C for binary floating point. So they added a whole new extension for binary floating point, and they also cleaned up a lot of the math in C. So they're now basically, I believe, almost perfectly conformant. There's some differences, but they're almost basically conformant with IEEE, the new floating point IEEE standard, the 2019 or 2021. And so basically they have all the functions, they have all the binary floating point functions, and I have to integrate that Annex X into the C standard, and that's what I'm doing right now, on top of all the other papers that got accepted. So I'm desperately beating the LaTeX up. God, I hate LaTeX so bad. It's not fun. It is absolutely not fun, but it's what we have. And I'm actually pretty grateful that it is LaTeX, because before it was some like prof and a mix of some other stuff, and which is like some like half dead file format. Jens Gusted, who's also spent a lot of time on the C committee, a lot more before I showed up, who is the one who's proposing lambdas and a bunch of other like revolutionary, even the null pointer constant, they're bringing that into C.
Oh wow.
So it's actually getting really spicy in there. Jens Gusted was the one who was the editor before me, and he did a lot of work to translate everything to LaTeX. And as much as I complain about the LaTeX experience, like there's some little parts that are left in the old trough for like for the way the old standard was, and I'm like, I'm so glad I never had to touch any of that, because it just looks like its own whole nightmare. So many thanks to Jens Gusted for that one. But yeah, I'm not having fun with LaTeX. I'm really not.
I don't know if it would be useful at all, but I would just share that there's been this WYSIWYG LaTeX editor that's been around for like 20 years that's not very well known, called Lyx, Lyx.
Lyx.
It might, if you haven't seen it, I mean, I haven't tried to use it in like 15 years, so I can't even comment on whether or not it's useful right now, but just thought I'd throw that out there.
Okay. Yeah, definitely. I mean, right now I'm using like VS Code and just like a bunch of like shell commands. I can't even run it in Windows right now. I mean, I'm trying to improve the build system so that I can build on both Windows and Linux. But right now I'm just it's all WSL2 land. It's all VS Code with just running raw commands and hoping the thing builds, and like getting a million spews of like overfull HBox. Overfull HBox, yes, overfull HBox. At least like thousands of those errors, and it's just not a good time.
And I'm sorry, I have to ask a question about what you said you're integrating. What the heck is binary floating point?
So binary, there's this binary floating point and decimal floating point. So they added extensions for both binary floating point and decimal floating point, which basically is just two different versions of handling different floating point numbers.
So like literally 1010.10.
Yeah, some of that, and then also a decimal version of that. So the format isn't exactly hammered in stone. I think implementation. I'm still trying to understand all of it, right? And this is why I'm taking so long to edit the things. I need to make sure that I'm putting everything in properly and not like, oops, I accidentally changed the meaning of what they meant by binary floating point. But it's basically there are two different storage formats, right? Binary floating point is the stuff you're already used to and what you get when you're floats and doubles today, right? It's a binary storage format. Decimal floating point is closer to what you would expect from your arbitrary digit precision libraries.
Okay.
So some of those storage formats, they don't support arbitrary digit floating point, obviously, but they support various different forms of decimal floating point, and that's basically what I've been dipping my hands into, and I'm learning way too much about floating point errors and other stuff that I need to make sure is is on point. I'm actually terrified of submitting the draft because I know that I'm going to mess something up, so there's a whole group body, the whole C floating point group, and I'm going to have to report to them, be like, so how badly did I do? But thankfully it's not too hard, right? Basically, most of it is just copy pasting verbatim and making sure that I get the typesetting correct. But again, in typesetting an entire annex of the C standard, it's something. So it's been taking me a while. Also, the diff engine is busted, so I have to fix that too. So there's a lot to do.
Oh man, are you glad you volunteered for this editing job?
Yes, with reservation. Yes, with reservations. But I am happy because I am getting a chance to revamp the paper process for C. So W21 has its paper system, right? And you can finally now submit papers online, and you get these P numbers, and they're not tied to the ISO system. C is still tied to the ISO system, so you have to submit a paper to the convener or to the what is it? I forget Daniel Polkosh's full title. But you basically submit it to either the convener or Daniel Polkosh, and that's how you get a paper number, and it goes through the ISO system, right? So they literally send an email or request to ISO. ISO approves that request, and then you get back a chunk of paper numbers, and you start handing them out, right? And that process can sometimes take an exorbitantly long amount of time. ISO is even complaining that we're asking for way too many papers. So we do need a new paper system. So I'm actually working on that, and I actually, for the next C mailing, I'm hoping to actually write one of the last n-numbered papers that is how to submit a paper under the new system, and I think it's pretty cool. And the good news about this is that it's, instead of kind of having things like WG21 link as separate services, it'll kind of built into the to the infrastructure of WG14. So I think it's going to be good. I don't have to do this stuff as a product editor, but I think it's still worthwhile to kind of give a place for people to easily submit their papers, because I've gotten way too many emails. But people are like, how do I submit a paper? And it's like, oh, well, you have to go through this very grueling process. Good luck.
Good luck.
And I'd like that to not be the case anymore. So I'm working a little bit on that. And hopefully, in the next mailing, I'll be submitting that paper that basically says, this is how we do papers from now on. Here's the website. Here's where you upload stuff. Let me know if things are broken. And then we can finally just migrate ourselves off of the always publishing on through ISO, which I think will be great. But yeah, that's basically everything I'm doing with the C committee.
To bring it back to C++, I know when you were on in November, we talked about the C++ and C working group. I don't remember what you call it, study group. How's that been going? The interaction.
Yeah, the liaison group. It's actually been pretty positive. So Aaron Bauman's been chairing that one and holding the reins on that one. So they're going through a lot of different papers, right? So they're talking about assert. They're talking about make sure lambdas are in sync. I think the biggest topic now is actually something that actually appeared in the latest mailing, the multi-dimensional subscript operator. That one allows you to basically define a subscript operator that takes multiple arguments, right? So basically they just, instead of restricting it to one argument, you can pass in 0 to many, right? It's variadic. And that generated a little bit of liaison discussion, where people were kind of the C people were a little bit grumbly that we were taking space from the C arrays, in that we were only We were defining this new syntax that had this idea that you could pass multiple arguments to arrays. And so that generated a little bit of grumble. And so some papers might show up there for the liaison group. But the liaison group has also been tackling other issues in C and C++. So secure clear, I think, was talked about a little bit in the liaison group, which is a function that basically is supposed to securely clear a block of memory, and a couple other things that were also discussed in the group. And I think it's going pretty well. One of the other things that I actually wrote a blog post about was the elifdef and elifindef, the preprocessor directives. So that was approved for C last meeting, which I'm super stoked about. I'm so glad that we finally plugged that hole. So if you've ever used this preprocessor, right, and you've typed in ifdef and you've done something, then you want to type elifdef and you want to type something. That elifdef is illegal. You can't write that because it's not part of the grammar. It was never part of the grammar, right? So even though it's like a natural thing that you would just expect to work, it doesn't. So C last meeting plugged that hole, right? And I wrote how in the blog post, and you can read the blog post. I'll just give a quick summary. I basically wrote how we were kind of doing the thing that we often do in the committee in C and C++, where we're like, this is a nice feature, but you can just write elif and then defined and then the thing, and you get the same behavior.
Yeah, right.
So why do we have to introduce these new tokens and these new preprocessor things? We don't need it. We can do it the other way. In fact, if we were being consistent, we would delete ifdef and just have if defined because that's more powerful, right? And we got on that bender for a little bit. But one of the things that actually makes, I think, elifdef and elifindef fascinating is that this is one of those things that, like, it's very simple, and so you think most people would be like, "What? Why would you care about it?" But turns out a lot of people care. In fact, we got an email from a senior embedded developer who's been at his job for like well over like a decade and a half, who's like, yes, please put this in. Like, I am sick of running into this problem. Please put it in. Like, if you can do anything to make sure that this makes it into the standard, do it. And so we got a bunch of emails like that. And so it was like, oh, okay, this is a kind of a win for us, right? Like, so even though it seems like something like it would be better if it would be better if we deleted ifdef and just went with if defined. This is one of those things where it's like, okay, well, we have ifdef, and it saves people some time. Maybe it's actually worth having the feature in, the language. And so that actually ended up turning the tides of the discussion and making it so that it was overwhelming, that there was overwhelming support for it. And I think it is one of those things where I was like, it often feels like when we're standardizing stuff, we're like detached from the community and we're never beholden to anyone. And we're just like, big, huge brain, super crazy theoretical standards people that don't think about other people. But it's actually important that you do reach out to us because we are grounded by what you say, right? If a bunch of senior embedded developers reach out to us and say, yes, please put it in, like that's a very strong pull to do the right thing. And so having that kind of support is actually pretty important, right? So I guess there's just a little bit of propaganda to say, email your friendly, proposal author if you're a you are a stakeholder in this, right? You ultimately end up working with the C standard, right? So like, yes, some of us do a lot of work to put the proposals out and do the work, right? But like, even just a small email, even just a small amount of user feedback does turn the tides for good. So, I think that's kind of a good thing that came out of that situation, that user feedback there is a connection between the committee and the end user, right? It's not just a committee sitting in some lofty tower being like, all right, I think today is the day we're going to introduce some undefined behavior today. Let's see how the peasants deal with that. Right? We're a little more rational than that, I think. So, I think that would be a little bit better. But yeah, so that also showed up in both C and C++, and I think it also got approved for C++ as well. So I'm sorry, it made it through the evolution group in C++. It got approved by the design group. So now it has to go through the wording group. And this is also kind of why I like the C committee a little bit better. Once your paper gets approved, it's in, right? There's no like multi-tiered stages, groups, go through the incubator first, then have a discussion, and then we'd have a vote and then the plenary and then this and that. There's like, no, we take the paper. Is it good enough to accept right now? Yes. Okay. It's in. No. Okay. You need to go back and work. Right. And it's very actionable feedback. It's very it's a very direct way of working on stuff. You can't ever get lost between groups or something or not know what's going on. So I think in that way, it's nicer, but it's also probably due to our size, right? Like we average 20, 25 people a meeting, 30 people a meeting. You can talk to everybody. You can have time during the meeting week to talk to everybody and you won't miss out. So, I think that's kind of a good thing. Yeah.
Was there any concern that some of these things like lambdas and deferred and whatever are going to make the language no longer simple and easy to implement, and the things that people like to say about C?
Yeah, so there is some concern that there actually is a lot of concern that these things are be difficult, but I think that a lot of people have recognized that that for all the things that people say C is simple about, C is actually not that simple. And also that C already has a lot of this, right? So like nested functions, our GC extension that's implemented by half people. Again, Borland has the double underscore closure keyword in there, right? There's a bunch of other statement expressions and being able to decay those to closures and function pointers and stuff. We already have that stuff. People have been basically compensating for C for a very long time, right?
Right.
And so a lot of people realize that, okay, so we're asking for this Lambda feature, but it's not really any different from what we've been literally implementing in our compilers, except everybody does it differently with subtly different semantics, with subtly different bugs and broken things. So maybe it's better if we actually just standardize on something that does a good job of it, that's been proven to do a good job of it from many other languages, to get it right. Now, there's other things about lambdas that are pretty scary, right? So with the lambdas, there's the simple lambdas proposal, there's lambdas with closures, and then there's a level 3, the boss level of lambdas, which is lambdas with auto. So so I worked on getting typeup into C, and that's going to hopefully get in this year. But Jens Gestad has been working on getting auto into the language.
Oh, wow.
And so that's auto for type deduction, but then he also proposed auto for lambdas. So if you have a bunch of lambda parameters and you sprinkle them with auto, it looks like you'll be able to basically have templates, but by the back door, right? So you can't name the templates, you can't name the types, you can't do anything with it, but it's kind of templates, right? And so what Jens and other people in C are trying to do is they're basically trying to have templates, but without any of the type baggage, right? So, you have these lambdas, these polymorphic lambdas that can do these things, that can kind of support type generic programming, but without introducing the entirety of the template system, right? So how do you mangle polymorphic lambda? Well, it's up to the compiler, right? The compiler can make a decision, right? So instead of enforcing a lot of these decisions that kind of came with the whole Turing complete template system, they're hoping to just kind of have this one thing, this one polymorphic lambda thing that you can do, that will kind of serve the purpose of what most of lambdas do. And I used it myself I prototyped a vector. I prototyped a vector in C using polymorphic lambdas, and it's actually pretty amazing, right? So I can have a single vec of int or vec of whatever structure, and I can ship that to these polymorphic lambdas that I basically have a bunch of them in the global namespace to like vec insert and vec whatever. And I don't have to make vec int insert. I don't have to make vec double insert. I don't have to duplicate the code at all. The polymorphic lambda will just do the same thing for all of them, right?
Right.
So I can effectively have a decent container library, right? The thing that people have been yearning for 30 years in C. You can have a decent container library without the templates, just using these polymorphic lambdas and stuff, right? So it's actually pretty exciting. I hope that people do look into it a little bit more. Right now, what people have to do is they have to do crazy amounts of macro generic programming, and it's horrible and ugly, and a lot of people hate it. But I think that this actually has some potential for really giving people a very good way of having reusable code and generic code in C that actually scales up to some degree, right? And again, we're not, lambdas, they're not real function things, right? So they don't have mangling. You don't have to worry about how I put them in my binary, right? It's all up to the compiler, and you can't observe it anyway. So it feels like we're getting a lot of the benefits of templates in a C-ish way that doesn't kind of allow the whole template system to come in and wreak havoc on what C's identity is supposed to be, right? Yeah. But even if we don't get polymorphic lambdas, just getting the simple lambdas where you can name parameters normally and it decays to a function pointer, and you can size of it, and you can set it to a void star and process as the void star argument to a callback and do all that shenanigans, I think is already top notch. So I'm actually happy. I'm kind of happy about the direction that's going in. Yeah.
Awesome.
Yeah, sounds exciting.
Yeah.
Well, we're starting to run low on time. A lot of interesting stuff is happening in the C committee, but I know one thing you announced on your blog that we definitely want to talk about is that you announced you're working on a new conference. Is that right?
Yes, I am working on a new conference. We have actually been working on it really, really hard. We've got sponsors, we've got music, we've got artists working. Yeah, music. Because again, it's going to be an online conference, like so that we actually have our own music and stuff like that, and people are working on that. We have artists working around the clock. But so this is slightly privileged information that it's CppCast exclusive. But it's unfortunately not the happiest of news because we're going to be postponing the conference, I think, until October 2022. The original goal was to have it October 2021, and that's what we're shooting for.
Oh, wow.
But that's a hyper aggressive timeline, and I mean we've been working on it for since December of last year.
So you're hoping for an in-person conference? Is that one reason why?
No, not an in-person conference. No. Okay. I mean we don't have the resources for that just quite yet. But we realized that if we held an online conference, especially our inaugural conference, that we have so many ideas for things we want to do that we would kind of run ourselves into the ground preparing for it by for October 2021, right? And even though it sounds like a very far time away, and even though we have sponsors who have signed up, and many thanks to them, and we have many trainers and speakers, some really high hitting and huge hitting classes that I was really excited about personally. I think that it's that Shepherd and all of us are kind of making the right call to delay it a little bit because I think the best way to capture it is that we have not stopped having ideas for things to do since December. And we have been pursuing every single one of them, and they're all turning out great. And we're kind of a little bit in trepidation that we will end up in a situation where we have all these great ideas and we don't present it as best as we can, especially for our first conference. And so I think Shepherd and the rest of Shepherd's Oasis is definitely making the right call, saying that it's probably a good idea to postpone it till October 2022 when we can definitely do it way better than we are right now. And so it's going to be basically postponed to October 22, which was sad because we just settled on the date October 2021 like a month and a half ago or so. So we were excited. I had the submission system ready to go. Like I coded up myself, and actually I coded in Rust, which was pretty cool. Don't tell any C programmers that I used C++ and C. It was great. But I was actually really excited about the whole thing. But I do think I agree with them in that we would do a much better job, I think, if we take our time and just definitely ship it out the door in 2022 rather than 2021. Plus, I mean, people are going through the vaccination. Like certain parts of the world are still not fully there yet. Other people are still trying to figure it out. I think by October we'd have a lot of it figured out. But at the same time, I think a lot of people would have a lot of online exhaustion, right? Constantly having to be at things online and stuff like that. I think that waiting the year is also just a good thing for that as well, because I think a lot of people, I know that this is especially because we covered live captioning. We already had live captioning scoped out and covered. We had a bunch of other accessibility features scoped out and covered. So I think a lot of the people who have disabilities will be kind of disappointed that we're pushing it back to 2022. But I think our conference will be even better for that, and we're going to have even more features for them and more ways for them to participate as well. Which it was another decision factoring into this for us, because we want to make sure this is an accessible conference. We want to do it a little bit differently than everybody else. Obviously, we're trying to pay our speakers as well, so that they actually feel like they're not just showing up for clout, but they're actually showing up because we value their time.
And not doing it just for the exposure.
Yeah,
I've seen this on Clients from Hell or whatever. People die from exposure, right?
Yeah, exactly, right. But so we have a lot of things that we're trying to execute on, and we just think it would be a much better conference if we wait till 2022, right? Thankfully, cash and everything wasn't really that much of a concern. We were doing very good on all that stuff, so I think hopefully the sponsors will still be interested in the 2022 conference. Hopefully, they'll kind of carry that energy of supporting a new conference that focuses on an inclusive environment that's welcoming to everybody, that gives you the tools and everything that you need to learn, and has great trainings and everything else. So I'm hoping that is going to be good. But yeah, I'm still a little bit disappointed, right? Because I wanted to hit hard with a 2021 conference, but the pragmatic decision should be made, so yeah.
Sure. Okay, well, we'll definitely have to talk more about it as we do get closer to that October 2022 date then. Okay.
Yeah, definitely. I'm going to be going on like I was actually already planning to do like a whirlwind tour of like talking at a bunch of places to advertise the conference. But for now, I guess I can still go to those places and just kind of talk about all the C and C++ stuff I'm doing, which I've somewhat secured this little bit hush hush, but somewhat secured a deal to start working on some.
This is a public podcast, just to make sure.
Yeah, no. Everything I'm saying, it can be said in public, but people are going to start noticing some commits coming from places that are going to be improving very specific things related to freestanding and related to embedded development that haven't quite been done before. And, I've been talking big game about, I can write a vector in 2 weeks and stuff like that. I think people are going to start seeing the fruits of that appearing in places that they can actually publicly access. And very soon. But I can't say more. It's all hush hush. But you're going to start seeing some serious improvements, and embedded developers are going to start seeing things that people like me and other people are taking their concerns seriously, and that all the hooting and hollering they've been doing has not been in vain. And so again, you heard it here first. So make sure you listen to CppCast and get the exclusive deets. Only here with Rob Jason.
All right. Well, I think that's a great note to end it on. Thanks so much for coming on again today, JeanHeyd.
Absolutely my pleasure.
That's great. Awesome. Thank you.